video, we'll take a look at some examples and some content from Chapter 7, 7.1, and 7.2. So in Section 7.1, the properties of a normal distribution. Before we take a look at the normal distribution, let's just take a look at distributions in general. A general definition of a probability density function is an equation used to compute probabilities of continuous random variables. We did discrete random variables back in the binomial section. The total area under the graph of the equation over all possible values of the random variable has to equal 1. So now we're looking at areas instead of adding probabilities together. And the height of the graph must be greater than or equal to 0 for all possible values of the random variable. So before we take a look at the normal distribution, let's take a look at a uniform probability distribution. If you remember, uniform meant that all possibilities were the same, all probabilities the same if it was discrete. For example, rolling a dice, the probability of getting a 1, 2, 3, 4, 5, or 6 are all 1/6. In this case, we're taking it over to an area instead of individual probabilities. So imagine a friend of yours is always late. Let the random variable x represent the time when you're supposed to meet your friend until he shows up. Suppose your friend could be on time, x equals 0, or up to 30 minutes late. So that represents our random variable of time on the x-axis, 0 to 30. For example, so with the intervals being equally likely. For example, your friend is just as likely to be 3 to 4 minutes late as he is to be 25 to 26 minutes late. The random variable x can be any value in the interval from 0 to 30. Because any two intervals of equal length between 0 and 30 are equally likely, the random variable x is said to follow a uniform probability distribution. So before we take a look at probabilities, we have the value of the random variable is between 0 and 30, but we need to know what the probability is. So the area of this rectangle is 1, so 30 times something is equal to 1. Divide both sides by 30. We end up with 1/30. That's how come the height of this rectangle is 1/30. So that means if we're equally likely between any 3 to 4 minutes or 5 to 6 minutes, the probability is always 1/30. So for our problem A, what's the probability your friend will be between 10 and 20 minutes late? So we're going to take a look at the area between 10 and 20 minutes late, and we've got a picture of this down below. So on the probability distribution, between 10 and 20 minutes late, find the area corresponding to that slice. So A, the area between 10 and 20 minutes late is 10, that's the width of this rectangle, and the height of the rectangle is 1/30. So we multiply 10 times 1/30 was a third. So the probability of being between 10 and 20 minutes late is 1/3. So that's this area. Second question, it's 10 a.m. There's a 20% probability your friend will arrive within the next how many minutes? So now we have an area of 0.2, and we want to know how many minutes until your friend arrives for 20% chance of being late. So set up in your area, find the value that satisfies the equation. 1/30 times what is equal to 0.2 for the area of that rectangle. Multiply both sides by 30, and we end up with 6. So that's uniform. You'll have one of those on the homework, but by far the homework will have more problems about normal distribution. This was just an example of a probability distribution, continuous, that wasn't just the normal. Next is normal distribution. This is what we'll be focusing on for most of the course from now on out. So a continuous random variable is normally distributed or has a normal probability distribution if its relative frequency histogram has the shape of a normal curve. So take a look. We've had histograms that look almost symmetric. This one is exactly symmetric. The probabilities of the normal curve, it's symmetric about the mean. The mean is in the middle. Mean, median, and mode are all the same, and the highest peak is at the mean. The normal curve has inflection points at the mean plus and minus 1 standard deviation. The area under the normal curve is 1. The area under the normal curve to the right of the mean is the area under the curve to the left of the mean, which equals 1/2. So the right-hand side and the left-hand side are exactly the same. As x increases without bound, the graph approaches but never reaches the horizontal axis, and as x decreases without bound, the graph approaches but never reaches the horizontal axis. So that means that the x-axis itself is a horizontal asymptote. Now what you've worked with on the normal distribution is you worked with the normal distribution in chapter 3. Okay, before we get there, I just want you to notice that every normal distribution has two things, the mean and a standard deviation. That's what defines your normal distribution. So back from chapter 3, the empirical rule said that about 68% of the data falls within 1 standard deviation, and that's an approximation. About 95% falls within 2 standard deviations of the mean, and about 99.7% falls within 3 standard deviations of the mean. So this is just a reminder that you've worked with the normal curve before, but we've just used approximations instead of finding areas exactly. So what does the area under the normal curve mean? Okay, so suppose a variable x is normally distributed with mean mu and standard deviation sigma. The area under the normal curve for any interval of values represents either the proportion of the population with the characteristic described by the interval, or the probability that a randomly selected individual from the population will have the characteristic. So it can be described as a proportion or as a probability. So let's interpret. So the problem is the serum total cholesterol for males 20 to 29 years old is approximately normally distributed with a mean equal to 180, let me write it up here, and a standard deviation of 36.2. And that's based on data obtained from the National Health and Nutrition Examination Survey. A says draw a normal curve with the parameters labeled. So we want to draw a normal distribution, just sketch. The mean is going to be 180. And then we're going to add 36.2 to get to the next value. Let me get a calculator. So we take 180. If we want to find label to the right, we add the standard deviation, 36.2. 216.2 would be 1 standard deviation. Add another 36.2. We end up with 252.4. We could keep going further. You usually go 2 or 3. On the left-hand side, we take 180 minus the standard deviation. So 180 minus 36.2 is 143.8. I'm going to subtract it twice. 2 standard deviations below is 107.5. So I have 143.8 and 107.6. So that's drawing a sketch of the normal curve. B says an individual with total cholesterol greater than 200 is considered to have high cholesterol. Shade the region under the normal curve to the right of x equals 200. So 200 is somewhere in between the mean and the first z here. So there's about 200. And it's considered high if it's 200 or higher. So that's the area that we're looking at. So there are 2 ways to interpret that. So part C, suppose the area under the normal curve to the right is 0.2903. So this area is 0.2903. We want to be able to interpret this in 2 ways. So interpretations. It's either the proportion of the population with the characteristic. So we could say proportion of the population with high cholesterol is 0.2903. So that's the first interpretation, is as a proportion. Or it could be a probability. The probability that one individual selected at random from the population the probability that one individual selected at random from the population has high cholesterol is 0.2903. So it's either a proportion of the population, or you could even say percent, 29.03% of the population has high cholesterol, or it's the probability that if you select one person at random, that that person has high cholesterol, and that would be 0.2903. So a couple of items on homework that have to do with this section. These are some practice problems. The graph to the right is the uniform probability density function for a friend who is X minutes late. Find the probability the friend is between 5 and 20 minutes late. So this is that uniform probability. So we have a rectangle, and we know the height of our rectangle is 1/30 and the width is 30. So probability that your friend is between 5 and 20 minutes late is the area corresponding to that rectangle. So between 5 and 20 is 15 minutes. So to find the probability for A, we take area is 15 minutes times 1/30, which is the height of the rectangle, which is 0.5 or 1/2. B, it's 10 a.m. There's a 20% probability the friend will arrive in how many minutes? So we have the same picture, except now we know the area is 0.2, and that equals 1/30 times whatever the x value is. So that's 1/30, so we're looking for the x. Multiply both sides, 0.2 times 30, 6 minutes. Okay? Second question, just to practice a little bit. The graph of a normal curve is given on the right. Use the graph to identify the values of the mean and the standard deviation. So the mean is going to be in the middle, 10, and standard deviation, since it's labeled 10, 12, 14, 16, 10, 8, 6, 4, what do you have to add to 10 to get 12? That would be 2, so the standard deviation is 2.